So when this thing says to sketch a graph of each of these functions, it is truly a rough sketch, and everything you see here, well, on this page is going to be in factored form. So we're just going to start with slightly obvious things like, well, x equals 3 and x equals -4. And so we'll put a dot at x equals +3, x equals -4. And the y-intercept is going to be what happens if we plug in a 0 here and here. We'll do it in our head. So 0 minus 3, so -3, 0 plus 4 is +4. -3 times 4 is going to give me +12, so my y-intercept is at 12. So if you want to write the coordinates, you can. You don't have to, but I'm going to write 0, 12. I'm also going to write 3, 0, and -4, 0. So, I'm sorry, that's -12. I apologize. I think I said that, but didn't write it. So it's -12, not +12, which is going to be down here somewhere. No big deal exactly where. And so it's going to look like this. Well, how do you know it does this and not the other way? Well, two reasons. I know the y-intercept is down here, and because it's down here, I got to go down and hit that point. Another reason is, check this out, this is an even function, 1 plus 1, and it has a positive leading coefficient, so a +1 here. So leading coefficient is positive, even degree, up, up. There you go. So let's do this next one. This one also has an even degree. So if you want to, you could say, well, the degree is 2, and the leading coefficient is +1. So even, positive, this is also going to be up, up, and it's going to go through, let's do this one faster. It's going to go through 0, +4. 0, 1, 2, 3, 4. And so there it is, right there, see? Pen got a little shaky right there, but it's general shape is okay. Okay, leading coefficient in this case is negative, and the degree is 1 and 1, so 2. And my x-intercepts are at 2 and 4. Notice they're the opposite. So because this has a leading coefficient of a negative and the degree is 2, so even degree, leading coefficient is negative, down, down. So it's going to be like down and then down. So it's going to go like that. Okay, as we get into the next ones, we're going to see that we have to do a little bit of factoring first. But once we do the factoring, it's smooth sailing. It's pretty easy. So let's just start factoring. And most everything else can be done in our head. We will write down the degree, which I will abbreviate as 2, and the leading coefficient, which is +1. And if you want to, you could just go ahead and do that through the rest of these. I choose not to, but you could. And so when we factor, we're going to have x plus 2, x plus 1. And so we're going to have x-intercepts at -1 and -2. The degree is even. The leading coefficient is positive, so it's going to be up, up. So it's going to go down, hit that point, and then come up and hit that one. And it's a parabola. That probably doesn't look like that. All right, I'm not doing y-intercepts here. I could. If I did, this one would be 2, so 2 is over here somewhere, I guess. Let's factor. Let's factor out a GCF here, x squared minus 3x minus 4. Okay, at some point in this, you're going to start realizing, well, I can do these and I don't need his help. So I'm probably going to kind of hang tight here in a minute and just do them, but not say anything. And so they are for your benefit to try on your own. So as you go through these notes, if you are watching this video and you're following along with these notes, then you need the practice, possibly. That's what we're going to be doing in class. So I recommend that you try these and try not to listen or to watch, but just glance up every now and then to make sure you're on the right track. So it's going to be kind of boring as I just start writing things. I'm going to start drawing arrows too, just to show it's down, up, or up, down, things like that. Probably should have done that here as well. 0, positive 4, and negative 1. There we go. I'm going to have to start down here and up here. Now you might be saying, well, how high do I go? How low do I go? Not going to worry about that right now. Not the issue. Let's go ahead and do the degree on this one. The degree is 2. Leading coefficient is negative. I recommend we factor out a -1 first, though. That's going to really make our life easier on this one. Anytime you see a negative in the front, factor it out. It'll make your life much easier, trust me. So that's going to happen here. It's going to happen here, 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 and here. Please don't just copy. Make sure you know what's going on. Factor out a -x, by the way. Instead of factoring out a negative and then factoring out an x, this one has a GCF. I do want to point out also that the fact that this is a -x does not change the fact that I have an x-intercept at 0. So if I said -x equals 0, like if I was to make a little equation out of that, I'd divide by -1, cancel those, and x would still equal 0. So still 0. Just throwing that out there. All the stuff comes from the chart. What now? Okay, this one is where things get a little tricky, and I am going to talk some through this one. If we wanted to graph this one on the calculator, we could, and I will go ahead and tell you what's going to happen. We're going to have an x-intercept at 3 and another x-intercept at, 3, so it's the same thing. Well, I can't cross it more than once. Things get a little tricky if I do that. So if you graphed it on the calculator, you would actually realize that it comes down and bounces off there and then comes back. So graphing it will show you this. Technically, it's really like x minus 3 squared. And this is what we consider to be a double root. It has a multiplicity of 2, sorry, because it's a double root. So boom, multiplicity of 2, and so it bounces off, and it doesn't pass through like a multiplicity of 1 would. There we go. Okay, let's talk about multiplicity again really quickly. If I have a root that happens more than once, I have a multiplicity on that root. This technically would be a multiplicity of 1. That's a multiplicity of 2. If you had a multiplicity of 3, then the graph would look like this, actually. So multiplicity of 3, my graph, wherever the root is, it would go kind of like a cubic graph. If I have a multiplicity of 2, it would bounce off. Maybe it does it down on the bottom like that, boing, like that. And then a multiplicity of 1 means it's just going to pass through. Maybe not a straight line, but it's just going to pass through like that.